Welcome to day number 8 of 30 days of CNCF projects. And today we are going to talk about OPA, Open Policy Agent, the project that allows you to control and enforce your policies in your applications, but also using Gatekeeper, you can control policies and enforce them in your Kubernetes clusters. In this video, we are going to talk about what is OPA, what is Gatekeeper, how can you enforce your policies in your Kubernetes clusters and outside of them, and also, obviously, do a demo. Let's go. OPA, Open Policy Agent, is an open source, general purpose policy engine that unifies policy enforcement across the stack. It means that instead of developing your own policy engine, you can just use OPA, add your own policy, which are very customizable, and in your application, you can query an API and ask, is this action or what the user is trying to do allowed or not? And OPA will get you a response if, based on the policy, the action you're trying to take is allowed or not. What does it mean that is general purpose? It can fit a wide variety of use cases. It means that it's not built for one use case, for example, just for Kubernetes enforcement or just for specific applications. The main capability it got is that you bring your own policies, general customized, you can use whatever you like, and then use the engine to take the decision. Let's take an example. So let's say in my system, I'm trying to make that users can edit only their own resources. So what I would do, I have my own backend application, which got a context, for example, in the request, who is the user and which resources they own. And also I deploy OPA and I put a policy that says that user can edit only their own resources. And anytime a user tries to delete a resource, I would go to OPA, ask, is this user allowed to take this action? And OPA will reply if it's allowed or denied. And based on that, I can take the action in my application. So instead of writing my own customized policy engine, I am just using OPA for that. What is unique about that is that OPA is very declarative. It's using a very unique language called Regu. And also I can use it in wide varieties of application and also deployment like Kubernetes on Envoy. We are going to talk about it later in this video. To use OPA, we need to take care for two main things. One is that we need to get a policy as an input because the engine needs to verify our context and query based on some rules, and the rules are the policies. And the other way is that we do need to query the engine somehow from someplace. Let's talk about the policy first. So policies in OPA defined in a language called Regu. Regu is a declarative language that allows us to define policies in a very easy way. We are going to see that later in the demo. The other part is how do we query the engine? There are wide varieties of ways, and we are going to talk about each one of them. The first one is in a use case when we have our own application and we do want to use OPA as our policy engine. And for that, we have two varieties of queries that we can do. One is that we can deploy OPA as a microservice in our own application and query it anytime we want to get an answer from the policy engine. It will do the question or the query using HTTP API. So OPA will be a microservice, our services will query it using APIs, and it will go to the policy and will decide based on the policy what it should do. The other way is not to deploy it as a microservice, but to use OPA library, meaning that we will add the library into our microservice and we will query inside it. It's less flexible way and not recommended as to deploy it as a microservice, but if you need to do that, you can do that too. Those are two ways to use OPA in our own code. But there are two main ways that we can use it too, and those are already packed and ready to use. Another very common use case is to use it for Envoy. We talked about Envoy in previous video, but we haven't discussed how it enforces some policies. So there is an integration between Envoy to enforce policies using OPA. For example, we don't want specific requests to come from specific IPs, users, whatever context we want to provide, and that can be done using OPA. So anytime a request will come in, Envoy will evaluate using OPA. So OPA will evaluate, but will allow or disallow the request to come in to Envoy, and Envoy will do based on OPA decision what it should do. And the last way is to deploy it on Kubernetes, meaning that OPA will be the policy engine for Kubernetes. Anytime we want to create a resource, the Kubernetes API will ask OPA, is this resource allowed to be created based on the policy? It can be because, I don't know, request and limits are not defined, and we do want to enforce all of our resources to our request and limits. So Kubernetes API using an admission controller will evaluate the YAML that we put in against Kubernetes. I want to walk you through 3 main value points on why OPA can be a really good choice for you. So the first one is the reuse of policy engines. Obviously, any application needs to have some permissions, RBAC, or policies in place. You can write the policy on your own and make it custom-made, but obviously using already deployed and ready one will be easier for you to use. You don't need to maintain, to code, and along the years it will be a code that someone will need to own and operate. And this is a big issue because OPA already tested, deployed with wide varieties of companies, so you can just use it. Other aspect is the ease of use. So as I said, because OPA is a project, it's easy to be deployed and scaled and already tested. The operational toil that you need in order to operate such a project and run it on your own will be much less than operate and code and test your own policy engine. And the last point would be the fact of how OPA works with policies. So OPA works in a way that policies decoupled from the code. This is something really interesting because when you code your own policy engine or your own permissions, you, in most of the cases, add some code or some logic into the policy engine, and it means that the policies are not decoupled from the code. And because OPA is like a packed policy engine and the policy is defined in Regu outside of it, it allows you to decouple it much easier and work with how policy engine should work. So those are main 3 value points why OPA can be a really good choice for you. I want to show you 3 main examples of how you can use OPA on your own system. So let's take a look about how it works with Kubernetes. And for example, we need to ensure that all of the images come from a trusted registry. So in here, this is the Regu code that would do that. We will deny any container image that doesn't start with our own registry, which is oli.com. We can also use it with Envoy, and Envoy will allow us, for example, to allow a front-end service to run GET on specific endpoint. We can see how do we define the endpoint, how do we get this information, and then we can deploy it and integrate that with Envoy. And obviously, how we can be integrated to our own application. So maybe, as we said previously, only the pet owner can update the pet information. So we will get the pet owner when we will make sure that the pet owner is actually the user ID trying to do the request, and then we can compare them. If you want to learn more about Regu and try to test your own policies, you can click on the Open in Playground. Styra, which is a company that got commercial product for OPA, developed this playground. It's a really great one because it allows you to test your own policies. You can define what the policy is, put in an input and get the output of the policy. This is really great to have some playground and even test your policies before you deploy them. After we understand what OPA is, let's talk about Gatekeeper. So OPA Gatekeeper, this is the name, is a specialized project providing first-class integration between OPA and Kubernetes. So Gatekeeper is a tool that integrates OPA with Kubernetes, allowing you to define policies in your Kubernetes clusters. So Gatekeeper just a tool that helps you to deploy OPA on Kubernetes and also integrate OPA to your Kubernetes cluster, meaning that now you can enforce and control policies in your Kubernetes clusters. So let's take an example. Let's say that we want our ratio between request and limit for each one of the pods that we deploy in our environment will be enforced. So anytime the request coming through the API that requests are not equal the limits, we don't want the resource to be created. And this is what OPA and Gatekeeper allows us together, to deploy it on a Kubernetes cluster, to define the policies, and then anytime someone will try to create a new resource, Gatekeeper and OPA will deny the request to create the resource. What is amazing about Gatekeeper that it's CRD based, so it allows us to control over OPA using CRDs and Kubernetes native statements and resources. How Gatekeeper works. What we want to achieve is that anytime a request will come into the Kubernetes API will ask OPA if this request is allowed or not. So Gatekeeper will deploy OPA on the cluster, but it will also make the Kubernetes API to evaluate each request using OPA policy engine and the policy we defined in the cluster. How do we do that? There is a mechanism in Kubernetes called admission controller and admission webhook that allows us to interfere in the time between the requests come in from the API before it written to etcd. So the Kubernetes API will ask OPA, is it allowed or not? And if the request is allowed, it will flow into what you know as the flow today. It will go into the etcd, write the request into the API. And if it's not, Kubernetes API will block the request and will give a response based on the policy that we define. Later in the demo, we are going to see how it looks on action. But there is one more aspect for that. We said that we want to decouple the policies from the policy engine. But what would happen if we will change the policy every 1 minute? As you know, in Kubernetes, when we change a config map, we do need to delete and recreate the pod. Config map values are fetched during the creation of the container. So Gatekeeper also deploy a way to dynamically change config maps. And basically when we do change our policy, a Gatekeeper will make sure that our OPA engine is up to date with the policy that we define. This is a different mechanism, and that will help you to maintain the decoupling between the policy engine and the actual code and the policy that we define. So now that we understand everything, let's see how Gatekeeper and OPA works in action. In the demo today, we are going to deploy OPA using Gatekeeper on our Kubernetes cluster and then enforce some policies and see how it looks in action. So for that, I'm going to use my Auto DevOps Tools repository. There is an OPA and Gatekeeper directory. I will add a link to the description below so you can run this demo on your own. So what we can see in here is that first of all, we need to deploy Gatekeeper. So we will add the repo and then we will deploy Gatekeeper on our cluster. It will create a new namespace. With Gatekeeper, what's going to be deployed is the CRDs that will allow us to create Gatekeeper or OPA resources in our cluster. So let's wait for it to be deployed. I can see it takes a while. And what we will do next is that we enforce the number of replicas in a specific deployment. What we want is to create a way that no one will deploy a deployment. I don't remember the value, but with less than 2 replicas. We want to have HA in our environment and no more than 10 replicas. In order to do that, we do need to define 2 different CRs. One is constraint template. Constraint template allow us to define a template for our own policy, and then we will deploy the CR called on the name that we define. So it basically will create a CRD, and we will use the CR in order to enforce this policy. It will allow you to do decoupling between the policy to the exact values that you want to have in place. This is really useful when you copy examples from the internet, because you can copy just the template and then use it on your own CR. So I can see that now Gatekeeper is running. Let's clear the screen and kubectl get pods -n Gatekeeper system. And we can see that we have the controller and controller manager and also the audit. Cool. Something else that we can see is that I don't remember how it called, API resources. And then we can see actually the admission being created, mutating webhook and validating webhook. So this is the resource that actually does the validation, the admission validating webhook. So if we will do kubectl get on all namespaces, we can see that one was created for Gatekeeper, and that will make Kubernetes API to go to Gatekeeper and OPA to validate anytime we get a request. So now we can try to create our own resources. And first of all, we will start with the policies. So as I said, we do have the constraint template. And in the constraint template, we define the template in general. By the way, we do have a way to define our what will be the description of it. So if something failed, the user will get the description. We will see that later. And then we will define the CRD. To be honest, I copied it, so you can copy that from me, or you can copy it from any other library that got those. You can change and then change the validation, change the replica limit, change what you check, but actually it works out of the box. What I want to do is add it to my cluster. So I will copy that. And I will deploy it. And as you can see, the constraint was created. I will delete. And if we will do get kubectl get CRDs, what we will see is that we do have, I'll try to make it a little bit bigger. We do have the Kubernetes replica limit, which is the new one that we just created. You can see that the time changed a little bit. Okay. What we are going to do next is that we are going to deploy those constraints. How do we do that? We are going to take this policy, but we can see that any deployment with less than 2 replicas and more than 10 will be denied from our cluster. So I will deploy that. You can see it was created. And now what we want to do is to test. So we got here a deployment that got like 12 replicas. Let's try to deploy it and see how it goes. As you may guess, it's forbidden. We can see that we got error from the Kubernetes server, and the admission webhook make it fail. We can identify in here that Gatekeeper was actually the source for the denial. And then we can see the message. Replica limits, the provided number of replica is not allowed for deployment. And here we can see also the ranges that is allowed for us. By the way, if we will take the same YAML and we will deploy it with 1 replica, it will fail for the same reason. But what would happen if we will deploy it with 3 replicas? that obviously will work, and the resources and the pods will be created. So now disallow deployment, so now we make it allowed, and now it works and the container will be created. Now let's move on to our second example. And in the second example, what we want is that, very common example, we don't want users to create pods with requests not equal to the limits. Maybe we do have a resource policy that we want to enforce for our users, and we will do that using OPA and Gatekeeper. So what we have in here is that constraint that will allow us to define that. I will show you how it looks, like the template for the constraints. So here I took it from the general libraries of Gatekeeper. If you want, you can click on the link and see the template. But in general, what it will do is that set the maximum ratio for container resource limits and requests. So what I will do, I will deploy it. I will add it to our cluster. Cool. And now we got the template. We can deploy our constraint. And our constraint will be on pods and not deployment. What's the difference is that if we do that for deployment, anytime a deployment will be created, it will enforce that. But in here, it will be anytime a pod will be created. So it's going to be a little bit different. I'm going to deploy the constraint or my policy. Clear. Okay, I don't know why it's stuck. And now we are going to deploy a deployment. To add a deployment, you can see that the request is 40 and the memory limit is 50. So what happens previously is that the deployment creation failed. But in here we can see that the deploy was created because the policy we deployed or the constraint we deployed was for pod, right? So anytime a pod will be created, that will fail. So what would be interesting is that now we do have a deployment. You can see the deployment in here, but it got like non-pods ready. And that's interesting because what we would take a look at next will be get pods, but they are not pods. Like we are looking for the disallow deployment too. So what we'd do next is that we want to describe the deployment and understand what's going on there. So we will do kubectl describe, deploy, and then our deployment. And what would happen in here is that the replica set is scaling to 2. That's interesting because it failed to create the replica set. So now we would do kubectl. I will clear so it will be easier for you to see. kubectl get replica set. And now we see that we have 2 of them, and now we can kubectl describe, kubectl describe replica set, and this replica set. And what you will see in here is why it failed to create. And it failed to create, and here we can see the admission webhook, the validation denied because container has no CPU limits and container has no CPU request. This is the previous, or this is both of them. And also container memory limit is higher than maximum allowed ratio. So because all of that, this pod was failed to be created because the enforcement was on the container. And this is a different way to enforce that. You can use both. You can use both ways to deploy it on the deployment level and also to enforce that on the deployment level, but also enforce that in the container and pod level. Obviously, I would not recommend to use the second option only because it's very confusing. So if you do want to have that, I would recommend to do both, like in deployment, so it will enforce when you create the deployment through the API, but also the pod, so if something slip in somehow, you will do have another mechanism to work with that. And this is the demo for today. I do recommend to go back to this repo Deploy it on your own. It takes only 5 minutes if you have Kind cluster up and running. That's it. And the last thing, and maybe the most important one, is to add the OPA sticker as day number 8. I really love this sticker because of the Viking helmet that we have there. That's it. Thank you very much. See you on day number 9.